Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Mod Pod's by Samu Piano and GDC. And here are the rules. Sudoku. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Mod P's. Digits on a line between two circles sum to a two-digit number. For instance, let's see if we can fit this. No, we can't. Oh, maybe we can. Okay, we can do it here, I think. Yeah. So for instance, 3, 3, 4, 6, 1 could be a valid split P line. So this is mod P's and split P's. So this could be a valid line because 3, 4, and 6 equals 13, which is 1 and 3 concatenated with 1 concatenated with 3. Furthermore, not including cells with circles, every set of 3 consecutive cells on a line must include a digit from 147, 258, and 369. So this would actually not fit the... Okay, so this is why it's called mod P's, because it's a combination of split P and modular lines. So modular lines, on modular lines, you always have to have one from the set of 147, which is 1 mod 3, one from the set of 258, which is 2 mod 3, and one from the set of 369, which is 0 mod 3. So if you take it, if you also have a number keypad, a number keypad on your keyboard, you can divide it up by columns of 147, 258, and 369, right? So that's how you always have on these lines. So not including the circles on the ends of the lines, but everything in between. You always have, if you have 3 digits that are consecutive, you always have 1 digit that is from 147, 1 digit that's from 258, and 1 digit from 369. But you're not sure what the order is. And that's mod P's, which is a combination, again, of split P lines and modular lines. Notes. Because cells containing circles do not have to follow the modular rule, every line is a different modular line. In other words, modular classes may repeat in less than a 3-cell span if a circle is between them. No bifurcation is necessary or allowed. I'm not sure what that means. But basically, yeah, it's saying that you don't, even though you ignore the circles, since these aren't 3 consecutive cells on the line, because the circle breaks it up, this set, you could have 2 from the same set here, right? Because they're not part of the same line, quote unquote. So that's just a clarification. And I don't know why the no bifurcation is necessary or allowed. Yeah. I mean, you could bifurcate if you wanted to, but... Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first things first then. You have 3 digits. Okay. Maybe that's not the best one to go to first. You have 1, 2, 3, 4. Let's start. Okay, this has to be 45. These are all 9 digits. And they're all in between these 2 circles. So this is 44 and 5. So this is 4 and 5. This is 4 and 5. Which means this cannot be 4 or 5. But that doesn't really tell us much. Anyways, let's start coloring. So we're going to make this orange, pink, and green here. So this is orange, pink, and green, and therefore this is orange, pink, or green. So along a modular line, since you have to have three of the same you have to have one of each set in every three adjacent cells. That what happens if we move from these three adjacent cells to these three adjacent cells? Well, these two cells stay the same, so we know that this has to be the same set as this one because we need one from every set. So that's how we know this coloring, which means this cannot be pink. Neither of these two can be pink because we have three pinks already in column 8. So therefore, none of these can be pink. So these two can't be pink. Well, we need, for every 3 set, we need at least one pink. Can't be these two, so this must be a pink. So this has to be some set of green and orange. This is some set of green or orange. Interesting. We know, okay, so one of these, out of these 4, only one can be orange. So orange is one of these two. And now we can be pink, green with the other sets, right? So orange has to be one of these two. This cannot be orange, then. Because we know 2 out of orange has to be here. So this is pink or green, right? This has 3 from orange, pink, and green. This has 3 from orange, pink, and green. Okay, that doesn't tell us very much. These again, so one of these is green, one of these is orange, which means this is green or orange, right? Because it's the same as this one. This technically could be green and green, right? Let's see, what else do we know? This must be the same as this. But it doesn't tell us very much. Green, pink. This has to be one of each. This is one of each. This is one of each. This must be the same as this one. So this is the same as this. Okay, so this one we're gonna name A and A. This has to be the same as that. That doesn't tell us anything though. This one we don't know anything about. So this can't be orange either. So this has to be green or pink. This can't be pink, so this is green or orange. Oh, these can't be pink. These are green or orange, and this has to be green or orange. Because all of these are pink. Um, hmm. This will go blue, red, and blue, yellow, and red. So this must be blue, which makes this yellow and this red. Right? This has one of each set here. So red cannot be here. Therefore, these are blue and yellow. We're not told much else here. This is the same as this. So this is B. That's the same as that set. Okay, so One thing about these numbers is it cannot be 40 something or 50 something to add it up to this, right? It has to be either 14, 15, or 24. So this is 1 or 2 by necessity. Right, so one of these, so it's probably 1, but we're not sure, right? This has 4 numbers, which add up to a 4 or 5. It still cannot be 40 something or obviously 50 something. So it has to be 1, 2, or it can't be 3 because it would have to be 30 then. Therefore, this is 1 or 2 also. Interesting. This is 1 or 2. This has to add up to at least 10. This still could be, yeah, that could be many things. So this is 45, this is 45. This can't be 4 or 5. This can't be 4 or 5. So this is 1, 2, 3, 6, 7, 8, 9. Because we know 1 is 4, 1 is 5. So this is 1, 2, 3, 6, 7, 8, 9 also. Hmm. This has to be the same set as this one. Let's make let's make this one the light, medium, and dark. So this is light, this is medium, and this is dark. So one of each is here. What does that mean? I'm not really sure. This is the same as this. This C has to be, so this color, sorry, whatever set this is, has to be the same set as that. But they're not the same digit, remember. The same here. We're just using A, B, and C because we don't want to have 18 colors. One of my viewers said that that made things difficult to follow, which I agree with. So we're just using A, B's, and C's now, just to get a sense. Though they are not the same number, remember. Hmm. So these are modulo, though. This is one of each. 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 So, if these are the same, that means it would be 14 or 25. And they would both have to be green. Hmm. But that doesn't really tell us very much. So again, this could be 10. I mean, it could be 30 something too, right? I see why they're saying bifurcation is no bifurcation is necessary or allowed, because there's a lot of possibilities if you go down that path. This has 3 of each. This is the same as that. So we're going to mark that D and D. Oh, interesting. So if these are the same, and therefore they're both green, what happens if it's 14, right? If it's 14, that means there's 2 greens here. There can only be 1 green here. So that means one of these has to be 1 or 7. But you can't have 7 without a 1. That adds up to 14, right? It would have to be 1, 3, 4, and no, 1, 2, 4, and 7 if you had 14, which is not possible. So therefore, this would have to be 1 and green. This would then be 7. This would be 5. So this would have to be 1 also. So this would then be 4, which would make that 1, if that's the case. Then what would you have? You can't have a 4 involved to add up to 14. Therefore, it would have to be you would have to have 1, no 4. So 1, 2, 3, 8 could work. So this could be 2 and 8. You don't have a 7 either. So it's no 1, no 4. So 1, 2, 3, 8 works. 1, 2, 5, 6 works. Yeah, that seems reasonable. What about if we tried to make this 24? If that's the case, this would be 2, this would be 4. This would have to be 7, 8, 9, right? So then this would be 5. You'd have 1, 3, 5, and 6 here. Seems fine. Three of the same. You have 2 of the same here. So if this is not 24, it would have to be 14 or 15 without a 1. So 14 without a 1. It would have to have three different modulos. Oh wait, it would have to be 15, right? Because it can't be, so this is either 24 or it's 15, right? Because these are three different sets. So it's 0 modulo 3, 1 modulo 3, or 2 modulo 3. And it has to contain all those sets, which add up to essentially 0 modulo 3. So this either is 15, or it's 24. Now, what does this add up to? This also has to be a multiple of 3, right? So therefore, this must add up to so this is a modulo of 3. This is 0. This adds up to 0 modulo 3. This adds up to 0 modulo 3. This also adds up to 0 modulo 3. Oh. Maybe that's how we're supposed to solve this. Okay. So these are opposite, essentially, sets. Not opposite, but they have to add up to 0 modulo 3. So whatever color this is has to be a different one than here. And these two sets are the same. We know that for certain because they have to add up to 0 mod 3 to add up to these three. Same with this. Same with this then. These, okay, so let's remove this. Let's go down this way. So this one we're going to make dark and we're going to make this medium. Therefore, this has to be dark to add up to 0 modulo 3. Right? Because we know these already add up to 0 modulo 3. So this is either 1 or 2. This is also 1 or 2. Which means this must be 1, 2, 4, 5, or 7, 8. So this is also the light, because we have 6 digits, 2 from 0 mod 3, 2 from 1 mod 3, and 2 from 2 mod 3, which all adds up to a 0 mod 3. So this is a how do you say it? A known fact, I guess, about things that are divisible by 3. Anything that's divisible by 3 must add up to, essentially, the digits must add up to, essentially, 0 mod 3 if it's divisible. And if it's not divisible, it'll add up to 1 plus or something like that. Yeah, right? So if it's equal to 1 mod 3, it will be essentially, you add up the digits, it'll be 1 plus that. So like, for example, 13 is 1 mod 3, so 1 plus 3 adds up to 4. That's 1 mod 3, so that fits that. Same thing with 52. Same thing with 51. Like, so for 51, you know that's divisible, but that's equal to 0 mod 3, because 5 plus 1 adds up to 6, which is divisible by 3. So then that is divisible, that is equal to 0 mod 3, right? So this has to be the same as this one, because we have 6 here. So therefore, this is the medium. And these have 3 adding up, and there's 1 from 0 mod 3, 1 from 1 mod 3, and 1 from 2 mod 3. So this also has to add up to 0 mod 3. Therefore, this is dark. Now, the same thing with that is here, right? Actually, we know this has to be the same as this. So therefore, this is also medium. And this, interestingly enough, so we know these add up to 0 mod 3, so this must be light medium also. So these have to be the same. We know then for certain they're the same. This can only be green or orange. This can only be pink or orange. Sorry, not pink or orange. This is green or orange. This is pink or green. So therefore, these must be the green then. And what I was going down this path has to be the same. Just because of that, these 3 add up to 0 mod 3, which means these 2 must add up to 0 mod 3. So we're labeling this a dark, and we're labeling this a medium. These 3 add up to 0 mod 3, so these 2 must also add up to 0 mod 3. Therefore, we have a medium and a dark gray. Same with these. This adds up to 0 mod 3 because there's 6 of them, and there's 2 of each set. So therefore, this is a medium gray too. These 3 add up to 0 mod 3, so these 2 must add up to 0 mod 3. Therefore, this is a dark. And we have 6 here, so this must add up to 0 mod 3. And so these 2 must add up to 0 mod 3. Therefore, this is a medium. So this is a medium, and this is a medium. Therefore, we know all the mediums are green, because it can't be orange, and it can't be pink, because if this was pink, if this was pink, this would also have to be pink, but that's not possible. Therefore, we know this can't be pink. Where are the pinks here? The pinks have to be specifically here, here, and here. So, one of these is orange, one of these is green. These rest are pink, so we can remove the D, because we see that they're the same one. So this is green, this is green. So whatever these are, whatever the C is, has to be the same as this, right? Because of the rule that I said, right? If you have whatever the sum of the digits add up to must be equal to the mod. If you take the mod 3 of that, that must be the same as the mod of everything that this sums up to, right? So therefore, this also is a C. But this is A and A too. So these all have to be the same. So we're going to make this, I don't even know. What do we make this? It's green or orange, so it can't be pink. These have to be the same as these. We'll make it just all A's. So these are all A's. Right? Because all of them are 3 plus an additional whatever modulo this is, right? So and this is the same. This is the same. So this has to be an A, which means these are the same too. So the B's all have to be A's. Wait, that doesn't work. Huh. That doesn't work because we have 4 A's then here. Ah, interesting. So that's an incorrect assumption I made then. But it has to be though, right? No, well, 3 and 1. 3 and 1. Well, we know that can't be the case because we have four eights then, if that's the case. Huh. Okay. One thing we do know is we know that the zero mod 3 works, right? Maybe that was incorrect in my assumption, like that it actually has to add up to one mod. If you have three that add to one mod 3, it has to be the same as the digits adding up the digits making up the sum adding up to one mod 3. I do know that if you for 0 mod 3 that definitely is the case. But it looks like 1 mod 3 and 2 mod 3 are not the case there. Because it can't be, because then this would be A, and that would be A also. Four, 1, 2, 3, 4, 1, 2, 3, 4. Then these would all be. Yeah. I do know that the anytime you have three. So first of all, you have anytime you have three from a set that's 0 mod 3, 1 mod 3, and 2 mod 3. It must be essentially equal to 0 mod 3, the sum. So therefore, and the digits, I know that does work. So if it's to be divisible by essentially 3, you have to add up to 0 mod 3 for the digits, right? So 15 works, 24 works, 14 does not work, 25 does not work because obviously 2 plus 5 is 7. Divided by 3, which would be 1 mod 3, so it's not. So therefore, this alternating thing does work. So we know these are the same. Hmm. This must be a different one then. So this is the same digit. Whatever digit is here has to be the same one here. Cannot be here, cannot be here. Can't be the same as this one. So I guess, yeah, this one doesn't work that way. Hmm. That doesn't seem right, though. We know it's 3 in a row, so therefore that's z mod 3. And then you have plus that. And if it's plus 0 mod 3, then this would be 0 mod 3. Uh... Yeah, this one seems a little weird. It almost seems like it has to be, right? But the problem is all three of these can't be the same modularity. Because then it would be the same modularity as that. This has to be the same set as this. This has to be the same set as this. And therefore it's 3, which is 0 mod 1, 0 mod 3, 1 mod 3, and 2 mod 3. All of them. And then that doesn't make any sense. Yeah, we have a problem there. Why doesn't that work? Oh. Right. This is a different set. That's why. Oh. Right. It's not the same set because this is... These two must add up to what this difference is. These two must add up to what this difference is, and these two must add up to what this difference is. That's why we... Yeah. Right. We were assuming that it was 0 here. Right? That's not correct. So this... And in fact, it's not specifically 0 mod 3. None of these are 0 mod 3, right? If this was dark mod 3, so say this was dark mod 3, that means they add up to 0 mod 3. Therefore, A, B, and C would have to be 0 mod 3. Well, actually, B would not be. A and C would have to be 0 mod 3. So if this was dark, because this adds up, these two add up to essentially 0 mod 3. C and A would have to be 0 mod 3 because they would have to add up to... These three would add up to 0 mod 3, and then plus C would have to be 0 mod 3. So yeah, everything I said previously was correct. It's just that I didn't take into account the sums, right? So these are all these two are the same, but this one's different. So therefore that allows this difference there. And A and C do not have to be the same one as this, same set as this one, but C has to be the same set as A. Because we know that essentially these two must add up to the same modularity as these two, right? Because this is the same set and this is the same set. So if it adds up to 0 mod 3 and this is dark gray, then that would work, right? So these would add up to 0 mod 3 and this would add up to 0 mod 3. Therefore, these would all be 0 mod 3, but they wouldn't be green. If these all add up to 1 mod 3, say this was a 2 and a 2 added together, or a 2 and a 3 added together, or 1 and a 3 added together, then this would also add up to 1 mod 3, and this would add up to 1 mod 3, so therefore both of these would have to be 1 mod 3. So these are all the same set. Therefore, these are all the same set, which means none of them can be here. So it cannot be this one. This then has to be an A. And it has to be either these two or these two, right? Because this one is the same set as that. These would be the same set, these would be the same set. And one of them has to be A. We're not sure which. Therefore, there's two of the same set here. Actually, no, it cannot be. One of them has to be light, has to be equal to these, and then the other one has to be the other one set here. So this is pink, this is pink, this is pink, this is pink. Therefore, one of these three is pink. We know two out of the three are here are pink. Hmm. So A is either green or orange. We're not sure which. This cannot be A. So this is the other one. Hmm. So So pink could be the same thing as dark gray, but we don't know. A. So say A was green. If A is green, that means this has to be not dark gray, but the third color. And it would be 3, 6, or 9, right? Because this would be 3, 6, or 9 with it. And this would specifically have to be 3. Because 4 digits can never add up to 60 something. But it can add up to 34 or 35. No, well, no. So this can never be 3, 6, or 9. So this is either green or it's dark. Huh. Right, because if this was a 3, 6, or 9, it could only be 3 because these are 4 digits that add up to 30 something. 30, and it has to be 34 here at minimum. But the problem is you have 3 digits adding up to 3 digits that have to be unique, that add up to that can add up to 24 at most. So therefore this digit would have to be 10 to add up to 34. And that 34 is the minimum here. So this cannot be, this has to be green or dark. We're not sure which. So we know A and B are different sets. We know that for certain. One of these is B. So A cannot be the same as green. This cannot be the same set. Because otherwise, if it were, then this would have to be the 3, 6, or 9, which it's not. So A has to be a different set, so A must be orange. Because it can't be pink. So the A is equal to orange. So these are all orange. So we can now remove the A part. So this is orange. This can't be orange then. This has to be green to maintain. So this can't be orange. This can't be orange. This is green or pink. And this is green or pink. So this is green. This is green. This is green. This is orange. Now, orange could be the same as dark. We don't know. right? So one of these is orange, the other one is orange here. So we have one orange here, one orange here. This is green or pink. Um, so this is orange and orange. This has to be green and pink. This is green or pink. Hmm. This cannot be orange. So this is green or pink also. Because if this was orange, this would have this the contradiction that I was or the paradox that I was running to was having issues, right? We know that these must add up to a different modulo as these two and these two. So therefore this extra one must be a different set than the others. If this is green, then the B has to be 0 mod 3 because these two add up to 0 mod 3. If it's dark, then the orange has to be 0 mod 3. Right? In addition, actually, this can never be 3 because we tried running into 34 or whatever, 40 30 something. It can't be 40 something. This has to be 1 or 2 also. But it could be the other version, right? Because we only have 4 digits that add up to it. And 3 of them are unique. Same here. This is 3 unique digits with 1 extra. That could be at most 33, but obviously this can't be 3. So therefore this is 1 or 2. And this is 1 or 2. It could be the same one. It could be the same digit. Or it could be different digits, right? So we have 1 green, 1 orange here. If this is dark, this has to be then, these have to be the 0 mod 3 set. If this is not dark, this is green then. Um, if it's 1 and 1, that means this becomes the 2 mod 3 set. So that would have to be the dark. If it's 2 and 2, that would also mean this would be the 1 mod 3 set. And therefore the dark would be the same as the orange. Interesting. So either this is 369 or it's dark. It can never be green. Right? Well, we already knew it couldn't be green, so therefore we always had it as orange. But the dark could also be orange too, right? So if this is green, then these become dark. If this is dark, then these have to be the 3, 6, and 9 ones. Huh. So if this is dark, if it's dark and dark, these become green, right? Because they add up to the other one. They don't add up to. So. ugh. Hmm. This also. We don't actually have any information about these because there's no restrictions. We just know that these are 4 and 5, so that restricts all 3 of these. But there's no restriction here. So 2 of these are orange. If this is dark, that means they're orange and they're the different one. So therefore, it would have to be pink. No, sorry, it would be orange either way. This would be pink then. 6 digits. Hmm. So say these were the same. So this is, we know these are the same. Say these are the same. So this would be 11. I don't think that works, right? These 3 plus this must add up to 11. So it's, oh, I guess it could be 2, 3, 4, and 2. In fact, it would have to be 2, 3, 4, and 2, right? So then this would be 4. So this would be 14. This would be 2. Therefore, that would be 4, 3. This would be 2. So this would be 2, 4, 3, 4, 2. This would be 15. But this would either be 41 or 14, which it can't be either. This can't be 5. So this would be 6, 7, 8. Cannot be 9. 6, 7, or 8. None of these could be 1. And they can't be, this would be 2, 3, and 5 at least. So that does not work. Because this is at minimum 16. So it can't be 11. Still could be 21, though. Perfectly fine. So say this is 2, so that would be 4, which would make this 2 and 5. So this would be 2. We're trying this being the same set, essentially. So this would have to add up to 25. This would add up to 25. This would be 7, 8, 9, obviously. This would be 22. This is at least 24, which is possible still. So far this is looking okay. This is 22, 22. So these would have to be the same as 4 and 7, 1 and 4. Right? Because these two add up to 22, therefore these must add up to 1 mod 3. Therefore these must be, one of these must be 1 mod 3. So this can't be 4 or 7. This would have to be 1. So to add up to, this would add up to 21. So this would have to be, it could be 4, 8, and 9. This is 4 and 7. This could be 8 and 9, or it's 4, 5, 9. Sorry, 7, 5, 9. It could not be 7, it could be 7, 6, 8 too. This would add up to 25. So this would have to also be, this would be 1 or 4. This can, sorry, 1 or 7. This would be 1, 4, or 7. So this would have to have maximum of 8. It would have to be then 1, 7. One of these has to be 1. Then if it's a maximum of 8, 25 minus 8 is 17. So therefore, 2 digits adding up to 17. Therefore, this is the maximum. Therefore, this has to be the maximum then. This would be 4. This would be then 8 and 9. So that would have to force that to be 7. This would not be 7. This would not be 7. We would have a 1, 7, 1, 7. So this all does seem okay. This would be 2. Ah, how would this fit? This doesn't work. Because this can no longer be 1. Because this would have to be the 1. So therefore, well, I'm my fault. I'm bifurcating here. But anyways, this can't be 2 and 1, so this is at minimum 24, which is already impossible. So this would not work. So we know then 11 doesn't work, 22 doesn't work, so this has to be some combination. So therefore this cannot be green. This has to be dark, which means dark is pink. Because dark and green add up to 0 mod 3, which means orange has to be the 0 mod 3. Well, we know dark is not 0 mod 3, so this one can't be dark. We know orange is the orange, therefore, so dark can't be green, dark can't be orange, therefore it must be the pink. So dark is the pink. We know this is pink and pink, which means it must add up to a green, because it cannot add up to orange. So therefore this is green, therefore this is green. So B's are the green. We don't know what they add up to though. So this is either 21 or this is 12. Right, which works because these are 3, 6, and 9. So this is 3, 6, and 9. This is 3, 6, and 9. This is 3, 6, and 9. So this has to be 3, 6, and 9. This is 3, 6, or 9. This is 3, 6, or 9. Same here. So this is 3, 6, or 9. So this is green and green. We don't know what that is, though. Could be red, yellow, or blue. This is pink and pink. We know one of these is pink, so red or yellow has to be pink. This cannot, none of these could be pink. So this has to be green or orange, specifically. And none of these can be pink, therefore this must be the pink. So we have 2 pinks here. We have a pink here. We know one of red or yellow has to be the pink. It cannot be blue. So blue has to be green or orange. One of red or yellow is the pink. We're not sure which. So the pink has to be here with the green or red. Same here. One of these is pink with the, green or orange. Therefore, the rest of the row cannot be pink because one of them's pink here, one is pink here, one is pink here. So this is green or orange. This is green or orange. This is green. This is green. So this is orange and pink. One of these is pink. One of them's orange. One of these is pink. Right. There has to be one of each here. And we know pink has to be one of these two. So one of these has to be blue. Sorry, both of these are the same. So it cannot be green. If this is green, we know one of green is here. And there will be 4 greens in all of these columns. Therefore, this has to be orange and orange. Which means orange has to be one of these. Green has to be one of these. Therefore, this cannot be orange. So this has to be green or pink. This can't be orange. One of orange is here. One of green is here. One of pink is here. So this is orange, orange here. One of orange has to be one of these two. This could be 2 oranges. We don't know. So these 2 are orange. One of these is orange. This is the pink, because one of these 2 is pink. One of these 2 is green. One of these 2 is green. One of these 2 is green. We have one pink here and one pink here, but we don't know anything about these. Huh. Hmm. So this is either 12 and 15, or it's 21 and 24. If it's 12 and 15, oh, that's interesting. So say this was then 1, 2. This would have to be 3 and 3. This would be 15. This would have to be 6 and 9, right? This is 12. I guess it could be 3 or 6 here. If this is 12 and that's 15, this adds up to already, what, 18? Yeah, 18. So this adds up to 27. I don't think that works, right? So say this is, again, 5, 24. This is 18. 27, it has to have at least 2 and 4. And this is at least 2 and 4. So that would be 6 and 12 plus 18 is 30, which is already greater than what this can be. So therefore, we know the greens are all 1, 4, and 7. So this is 4, this is 5, that's 45. This has to be 15. This is 21. This is 14. So this is 1, 4, 7. The pinks are 2, 5, and 8. So this is 2, 5, 8. This is 2, 5, 8. This must add up to 14 without a 4. So this is what we were calculating earlier, way back when. This could be 21 or 12. We don't know which. Probably 21, but we don't know. This has to be 24 because it can't be 42. This adds up to 14. So 1 cannot be here or here. Can you ever have 14 without a 1 and a 4? No. It's 2, 3, 5, and 6 at minimum, which would be 16. So therefore, you need a 1. Cannot be here. Therefore, this must be a 1. And it cannot be orange. Therefore, this is green, which means this can't be green. This has to be the orange. So we have 3 greens now in box 6. The rest of the box cannot be green. So this has to be orange. This is pink. This becomes orange then because we need 3 oranges. So these are pink. So we have 2 pinks here. One of these has to be with this. So these 2 are the same set. So again, these would be A and A. This would be A, and this is A. But there also has to be another A in one of these two cells. So these cannot be pink. So therefore, A cannot be pink. It can't be orange already. So A has to be the green. Whoops. So this cannot be pink. This has to be green, which means this is green. So A's, yeah, we can just delete the A's. This has to be 1 or 7. This is 1, 4, or 7. These are 2, 5, 8, not 7, 2, 5, 8, 2, 5, 8, 2, 5, 8. We need 14 with 2 out of 2, 5, and 8. It could be 2, 8, and 3. What else could it be? 2, 5, and 6, right? So this has to be 7. So this has to be 1 or 4. So therefore, this is 4. This is 1. This has to be 7. The 4 has to be one of these two. The 7 has to be one of these two. So this is 2 and 5 or 2 and 8. So this is 5 or 8. Right? Because this is 3 or 6. So 9 has to be one of these two in column 9. Therefore, this can't be 9. This is 3, 6, and 9. This can't be 2 anymore. One of the greens has to be here. 2 cannot be here. 2 could... Okay, so this can't be 2. Therefore, the 2 has to be one of these two. Therefore, these can't be 2. Therefore, the 2 has to be one of these two. This is 3, 6, and 9. This is 3, 6, and 9. This cannot be orange. So this is green or pink. Okay, we have 3 greens in row 4. So the rest of the row cannot be green or pink. Sorry, cannot be green. So it's pink or orange, right? We know one of these is pink or orange, and the other one is pink or orange. So therefore, this is 2 pinks, and therefore this is a 3rd pink. Therefore, this cannot be pink. This has to be the orange, which means this can't be orange. This is green or pink in, and this is green or pink. So this is orange or pink. Yeah. So we have 3 oranges. This can't be 3, 6, or 9. So it's 1, 7, or 8. So this is 7. It must add up to 24. What did these add up to is the question. So 7 has to be one of these two here. And then it's with 2, 5, or 8. And this is 4 with 2, 5, or 8. Or not 2, 5, or 8. This is 4 with 3, 6, or 9. Right. Um, 3, 6, 9, 3, 6, 9. So 1 of 5 or 8 is here. We know one of these has to be pink. One of these is pink, one of these is green. One of these is pink, or 2 of these are pink. Therefore, we have 3 pinks in row 5. Therefore, this cannot be pink. This has to be green, which means this can't be green. This is pink. Okay, that's fine. One of these is pink, one of these is green. We're not sure which. This has to be 4. Which makes this, well, we don't know. This is 1 or 7. Okay, so this is 4. This is 5 or 8. Again, this could be 2, 8, and 3, or 2, 5, and 6. This is 2, 5, and 8. So this can't be 5. This is 15. It could be also 15 here. We don't know. So 1 cannot be here. 1 has to be here then. So 1 has to be here, which means this cannot be 20-something. That can't be 21. So it's either 12, 15, or 18. Not sure. So this could be 22. What do we have here? This is 3, 6, or 9. And this is 5 or 8 with 3, 6, or 9. We know the 4 has to be one of these 3. I'm not sure what, though. This adds up to 15 without a 7, so it has to have a 4. So that means the other 2 add up to 11. So it's either 4, so this can't be 4. So this is not the green. This has to be orange or pink. So it's either 2, 9, or it's 3, 8 with 4. It cannot be 5, 6. It cannot be 4, 7, obviously. So this is 2, 9, 4 with 2 and 9, or 3 and 8. So this can't be 4. Yeah. This is either 12, 15, or 18. There's no 4. It can never be 18 because this is 1. Actually, wait, it could be... No, it cannot be 8 and 9 because if this is 8 and 9, that eliminates all possibilities here. Right. So this cannot be 18. It has to be 12 or 15. This is 24, or not 24. This is 2. This is 4. So this is 1, 5, 7, 8. We know this is 2, and it's with 3, 6, or 9. So you have a 2 here. 1 of 3, 6, or 9 is here. That doesn't tell us very much. This could be 21. But it'd have to be 1, 2. Okay, it cannot be. No, it could be 3, 6, 4, 5. It's possible. What does that mean, though? So this is not 4. Well, it could be 4. It's 4 or 7. We don't know what this adds up to, though. We have orange, orange. This is one of each. Okay, if this is 5, it can't be 50-something. And this would have to be 15. But there's 6 digits there, unique digits. And that can't add up to 15, so it adds up 20. So this can never be 5. So therefore, this has to be 12 then. We tried 18. That doesn't work because this is 1, 8, and 9 then. And therefore, that eliminates all possibilities here. Because this has to have a 4. And we don't know what the 2 or... It cannot be with 4, 7, obviously, because there'd be 4, 4, 7. It can't be 5, 6 because the 5 is there. So it has to be 2, 9, or 3, 8. So therefore, 1, 8, 9 is not possible. Therefore, we know this adds up to 12. And it's 1. It cannot be 2. it's at minimum 5. So it could be 158. Sorry, 156. So this is 156, or it's 138. So this is 3 or 6. This is 3 or 6. Which means this cannot, none of the rest of the cells can contain 3 or 6. So therefore, this cannot be 3 and 8. It must be 2, 4, 9. Therefore, this can't be 2, 4, 9. This can't be 9. This is 3 or 6. This is 3 or 6 with 5 or 8. Yeah, we don't know anything else about this. This still could be 21, I guess. It'd be 1, 2, 3, 4, 5, 6. So this would be 4, this would be 1. It could be 24, it could be 27. It cannot be 12. It cannot be 42. So this is 20-something. It's 21, 24, or 27. Can you ever have a 9? I think so, right? Yeah. But if this is 27, this would have to be 27 also, and 3 digits cannot add up to 27. So this can't be 27. If this is 24, it could add up to 24. And if it's 21 here, this could add up to 15 or 12 or 18. All of those work. It just can't be 27, because then this would add up to 27, and that's not possible. So this is 5 or 8. So it's 21 or it's 24. If it's 21, it's 1 through 6. But the 6 could go up 3 for the 9, right? We do know the 3 has to be there, though. So this is 6 or 9. It could be 4 and 7. No, it can't be 4 and 7. It has to be 1. 1 has to be one of these two. Because it has to be 1. The 4 would jump up to a 7, right? So that'd be the 3 degrees of freedom we lose from going from 21 to 24. So but the 1 always has to be here. The 2 always has to be here. The 3 has to be one of these 4. The 5 could jump up to an 8. Right. Okay, so this adds up to 24. This adds up to 21 or 12. This is 12. 24 here. Can this ever be 3 and 6? If this is 3 and 6, that adds up to 9 plus 7. Actually, I think it has to add up to 3 and 6, right? Say this is 5. No, that adds up to 12, so it could be 3 and 9. So if this is 5, that adds up to 12, so this must add up to 12, so therefore it's 3 and 9. If this is 8, this adds up to 8 and 7. So this adds up to 8 and 7, 15. So this would have to add up to 9. So therefore it would be 3 and 6. So 3, either way, has to be one of these two, which means this can never be 3. So this can never be 12 then, because it would be 6 plus 1 plus 5 at minimum. So this would be 6, 1, 5. That doesn't work. Therefore, it must be 21. So if this is 7... I guess it could be 5 and 6. So this has to add up to at least 15, right? Because this is 3 or 6, and this has to be 2, 4, 9. We have 3, 6, 7, 8 here. This is also 3, 6, 7, 8. So this is orange or... yeah. One of these is green. We're not sure which. So this is 4 or 7. This is 4 or 7, which means 1 has to be one of these two. right? If it's not, one can't be here, one can't be here. We know one can't be here because this can't be a green, can't be 1 mod 3. Therefore, this is 1. So this is always 1, which means 1 has to be one of these 3 also. This is not green, so this is orange or pink. We already have 1 here. Yeah, we just are not sure about this one. So this can't be 1, obviously. So one of these 2 is 1. Hmm. So this is either 22, 25, or 28. Can it ever be 28 is the question, right? This would have to be then 7, 8, and 9. That's possible. Yeah. Yeah, and this would be 4, obviously. 22, can this ever be 4 is part of the question then, too. This is 4 or 7. One of these is 4 or 7. So the rest of 4 or 7 cannot be here. So this would be 1. Obviously, this is 2, 5, or 8. Hmm. So either this is 5 or this is 5, but we're not really told much. Hmm. So whatever's in these 2 digits are in these 2 digits, which must be the same as these 2 digits. Whatever's here, we're gonna make this blue, I guess. Pink and blue has to be here. And it has to be the same as this one. Okay. That doesn't really tell us much, but yeah. Um, hmm. Okay. Yeah, this could be a broad range of things. Say this was 9. This would be 3, 6. This would be 8. If this is 9, this is at least 12. This would be at least 9. So this would have to be a 1. This can never be 4. If this is 4, that makes this 21, but then this would have to add up to 1 through 6. And the 4 would have to be there. So this can never be 4. Can never be 4. If this is 4, this could still be 21. If this is 4, this would have to be 24. We also know the 4 has to be one of these 3. Hmm. Not really giving us much information there. Yeah, I don't know about this no bifurcation because we're essentially bifurcating here by basically testing these things. I don't know. Anyways. Um, if this is 8, this has to be 1. So therefore this would be, because it cannot be 48, obviously. So it'd have to be 18. But this could be 12 also. There's no 1 here, though. So I guess it could be 3 and 4? Huh. Actually, what is... Yeah. If this is 2, obviously can't be 12 because this is at minimum 10. This is at minimum 3. That's 13. So it would have to be 21. You would have to have a 1. Would you? You could have a 4 twice. And then a 2 twice? It would have to be a 3 twice, right? And then you'd have to have 2 and 5. Well, this can't be 4, though. This could be 4. So it would have to be 4, 1. Interesting. Hmm. Hold up. What can this be? This can't be 51. Because this would be 6, 7, 8, 9 at most. And this would be 8, 9 at most. So that would be 30 plus 17, which is 47. So you can never get 51. Can you ever get 15 or 18 is the question, right? 15, this is at minimum 10. And it has to be 3 and 6 with 2 and 4. So this is at minimum 2, 3, 4, 6. That adds up to 6 plus 6 plus 3, which is 15. And this could be 1, 2. So this can never be 5 here. If this was 5, that would be 15. And therefore, that's not possible because we know this is at minimum 15. So it could be 18 or it's 21. It can't be 12 either. So therefore, this is 18 or it's 21. If it's 18, this is 2, 4, 5, 6, and this is 1, 2. If it's 21, can you ever have a 9? I don't think so, right? I think this still has to be 3, 6. If you tried to have a 9, say you have 3, 9. This is at minimum 2, 4. Oh, I guess you could. 1 and 2, right? So 3, 9 is 12, plus 2, 4 is... Yeah, you could have 1, 2 here, too. What you cannot have is 7 or 8 here, right? This is at least 2, 3, 4, 6, which is 15. This is at minimum then, at maximum, has to add up to 6 or less. So therefore, it cannot have a 7 or 8. We know then this has to be an pink because it can't be green anymore. So this is pink, which means this can't be pink. This has to be green, and it's a 7. So this is 7. This is pink, which forces this to be pink. So this cannot be pink. Sorry, cannot be green. Therefore, this is the green. And therefore, this is green. So this can't be 2. It has to be 5 or 8 at minimum. And this is 4 or 7 at minimum because it can't be 1. Therefore, this can't be green because we have 3 greens now in the box. So this can't be green. This has to be orange. And it's 3, 6, or 9. We have also all 5, sorry, not all 5, all 3 pinks in column 5. That's why I was thinking of 5. Therefore, there cannot be another pink in column 5. Therefore, this is orange, which means this can't be orange. This is pink. This can't be orange. This is pink. So we have all 3 oranges in box 2. Therefore, those are 2 pinks now. So this is 2, 5, 8. This is 2, 5, 8. We now know this is at minimum 4, 5, 3, and 6. which adds up to 18. So this cannot be 18 anymore, therefore this has to be 21. So since this is 21, this is at minimum 4, 5, 3, and 6. It has to be specifically 4, 5, 3, and 6. So this is 4, 5, 3, 6, which means 9 has to be here. This can't be 5. This has to be 8. This has to be 7 and 9. You can never add, it could be 5, so this still could be 21 or 24. This has to be 1 then, this has to be 2. This can't be 2 or 8, so this is 5. This can't be 5 or 8, so therefore this is 2. This can't be 2, this is 5 or 8. So this adds up to 21, because you have 3, 4, 5, 6 here. This can't be 5, this can't be 5. This has to be a 7. So this adds up to 24. Sorry, 22. So these 3 must add up to 18. So therefore, these 2 must add up to 11. So it's either 2, 9, or 3, 8. We have all... Okay, so this is now... We have all the oranges and all the pinks. This has to be 8 also. We have all the oranges and all the pinks in column 5. So therefore, the rest are greens. Therefore, these have to be green. This can't be 4 or 7, so this is 4, and therefore this is 7, which makes this 1. This can't be 7. This can't be 4. So this is, this can't be 7 either. So the 7 has to be one of these two. Let's see. This adds up to 9. Therefore, these two must add up to 12. But either of those are fine right now. Similarly, if this is 7, 9, this could be 5, and that's 1, or this is 8, and that's 4. Either of those work. Huh. Okay. This can't be 5. Oh, okay. This can't be 5 because of this 5. Therefore, this is an 8, which forces this to be 24. Therefore, one of these, it has 1 through 6, plus one of the 4 through 6 can jump up to 7 through 9. Has to jump up to 7 through 9, I should say, probably. So we've got this already calculated. This is calculated. We haven't... this is not really calculated here. This can't be 1. So this is 7 or 8. This can't be 8, so this is 7, which makes this 5. So this is not pink, so it's green. This can't be green, so it's pink. One of these is 1. One of these is 7. One of these is... Where is the 9 in column 7? It has to be here. Because it cannot be in this one, it cannot be this one anymore. So this is 9, which means this can't be 9. So this is 3, 6. We have a 3, 6, 3, 6 pair here. We had a 3, 6, 3, 6 pair here. Also, actually, now we know this adds up to 14, and it's 1, 2, 5, and 6. So this is 6, now this is 3. It's probably going to give us a lot of Sudoku things. So therefore, this can't be 6. This is 6. This is 3 and 9, therefore. Which means this can't be 3, so this is 6. So this is 1, 8, and 6. That adds up to 15. To add up to 21, this must be 6. So therefore, this is 6, which makes that 3, which makes that 6. This can't be 3 or 6, so this is 9. That means this is 12, plus 7 is 19. plus 5 makes 24. So this is 5, this is 8. This can no longer be 5. Aha! So this has to have an 8. This has to add up to 24 with 8. And without another 5. So it cannot be 1 here. So this can't be 1. This has to be the 1. And this is 4, 5, and 7. We know this is 2 and 3. But 8 has to be one of these two. This can't be 6 anymore. This can't be 6. This can't be 9. So therefore this is 2. This is 9. Which makes this an 8. Which makes this 8 and 3. Which makes this 9. So therefore this is the 2. This can't be 9 or 6. So this is 3. Which makes that 8. Which makes this 3. So this can no longer be 3. This can't be 6. This must be 9. This can't be 9 or 6, so this is 3. This can't be, which we celebrate. This can't be 3, so this is 6. This can no longer be 1, 5, 6, so this is 1, 3, 8, which means this can't be 8. This is a 5. This can't be 2 or 5, so therefore this is 8. This is 2. Therefore, this is a 5, 7 pair. Then this has to be 4, 6, and 9. So we can delete the outside. This can't be 1 anymore. This can't be 4, obviously. We know the 8 is here. So it's 8 plus 1 plus 2 plus 3. Okay, this can't be 3 anymore. So either this is 6 or 9, or this is 4 or 7. But the thing is, you have an 8 here, right? So what's the minimum for this set of 6 digits? It's 1, 2, 3, which is 6, plus 8, because we know the 8's there. So it's 1, 2, 3, 6, plus 8, which is 14, plus at minimum 4 and 6. So it has to be the minimum then. Therefore, this has to be 6 and 8. This has to be 9. This has to be 4, and this can no longer be 4. So this is 6 and 8. Now this can't be 8 anymore, therefore this is 3. This can't be 4 or 9, therefore this is 6, so these can't be 6. This can't be 4, so this is 9, which makes that a 4. This can't be 2, so this must be 3, which makes that a 2, which means this cannot be pink. This has to be the blue, and that can't be blue, which means this is pink. Therefore, this one has to be the pink, which means it has to be the 8, and this has to be the orange, which means it's a 6. 8 cannot be here anymore, therefore this must be 1. This must be 8. This can't be 1 anymore. Therefore, this is 1. We have a 5, 7, 5, 7 pair in column 2. Therefore, the rest of the column cannot contain a 5 or 7. Therefore, this is a 9, which makes this a 7. This can no longer be 3 or 9 or 6, so this must be 4. This can't be 3, 6, or 4, so this is 9. So this has to be green. This can't be green. This must be orange. This must be green, and this must be pink, which makes this a 5. So this is 5. Oh, what did I do here? This is a 5. This can no longer be 5. This is 7. This is 5, which makes this a 7 and this a 5. So this can't be green. This can't be pink. This has to be the 3 and 6, and they're both oranges. And that's a solve. Yeah, it was difficult, definitely, but there was a certain logic to it. I still don't understand the whole bifurcation. What is considered bifurcation there, really? Because you're going down the path of, oh, well, if it's this, then it can't be this, or whatever. And that leads to a problem. If it's this, it can't be that. That's essentially bifurcation in itself, if you think about it. Anyways, this can't be green, and this can't be orange. The blues are not the blues. They are actually orange. Yeah. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.